well as the UN Water Learning Center for the Arab region at the Arabian Gulf University. He serves as the chairperson of the Technical Advisory Committee of the Water Resources Council of the Kingdom of Bahrain. He served as the Arabian Gulf University's vice president for academic affairs between 2008 and 2010, and the dean of College of Graduate Studies between 2010 and 2013. He obtained his master's degree in 1987 in the field of groundwater mathematical modeling from Ohio University, and PhD degree in the same field from Colorado State University, and joined Arabian Gulf University in 1990. Since joining AGU, he has taught many courses in hydrogeology, water resources management, and planning in arid regions. He serves as the visiting professor for the Paris Sorbonne University in Abu Dhabi. Dr. Zubari has published more than 100 research papers in peer-reviewed journals, book chapters, conferences, and seminars, and he has supervised more than 45 master's and PhD theses. His research interests include the water, energy, food security nexus, water resources governance, planning and management, use of numerical models in the management of groundwater systems, and the impacts of climate change on the water sector. He served as the editor-in-chief of the regional Arab Gulf Journal of Science Research during the period 2006 through 2010. He has conducted more than 40 contractual research studies and serves as a consultant for many UN international organizations. He has been an active member in the GCC Water Science and Technology Association and currently serves as its vice president and chairperson of its scientific committee. With that, Dr. Waleed, welcome to this webinar, and we are pleased to have you tonight, and we're very excited to listen to what you've got for us. The floor is yours.
Can you hear me, Abdullah? Hello?
Yes, yes.
Okay, thank you. I think I talked without having, when I was muted, so I just unmuted myself. Let me start by saying thank you for having me today with you and providing me with the opportunity to discuss with you a very important issue. That's the water issue. That's not only for those people who are specializing in water, but everybody that lives on this planet. And if I would go to the presentation, I would like you to look at the title. And I think before we get into the details of this presentation, I think we have to stop and reflect and discuss the term sustainability. I think this is very important, and I think we have to start thinking about it very, very seriously. We should start asking a number of questions here. We say, let's ask ourselves a question like, can we have sustainable water in the desert, in an arid region? Can we have sustainability for groundwater resources that are not replenished? They are fossil groundwater. Can we have sustainable desalination, which is one of the main sources of water supply we have? So I'm not sure if we're going to get out from this lecture with an answer to this, but I think we will be having a number of conceptual thinking and ideas or perspective. I think we will be reaching the point saying that, yes, if I want to have sustainability, I have to provide adequate water supply with a good quality, but at the minimum cost possible on the long run. That's why the first principle. The second principle, I should be using this water to maximize the benefit and provide the maximum added value from each drop of water to my socio-economic development. Now, this is the type of thinking that I would like you to get out from this lecture, and forget about all the details. But if we can reach this level of understanding and thinking and perspective of what do we mean by sustainable water management system, I think I will be reaching my objective. So let me start before going to the presentation by giving an overview of what I'm going to be covering. I'm going to have a quick introduction on what happened to the GCC countries in terms of socio-economic development and the accelerated development. Then I'll try to diagnose the water sector in the GCC. I'm going to try to present the main challenges faced in the GCC. This is not necessarily all the countries are facing the same challenges, but at least this is the common denominator challenges that we have reached when we worked on the Unified Water Strategy for the GCC. And then after this diagnosis, we will move a little bit to the prognosis by pushing something that we have worked on. All GCC people have worked on Unified Water Strategy by a directive from the higher council of the GCC, the leaders of the GCC. And I'm going to try to just extract certain strategies or policies that related to the groundwater, since the audience is mainly coming from the groundwater or from the conventional water resources. And I'm going to just present some of the future scenarios and cost analysis that we have done in terms of modeling the whole system and seeing what will happen in the next 20 years. We did this in 2016, and we have done this to the year 2035. So that was 20 years span. And then hopefully we'll come up with some conclusion recommendation. And finally, I'll give the credit to the people who have worked with me on this project. So let's start by a very quick introduction. I think I don't have to convince you that we are living in a very arid to extremely arid environment. We don't have a lot of rainfall, and we have very high evaporation rates, and of course that make it impossible for a perennial surface water system to exist in our region. We have limited renewable groundwater resources that we rely on, and they are mainly located in the mountains of Oman and the western mountains of Saudi Arabia. This is a simulation, or let's say an animation of the precipitation, runoff, and soil moisture for the globe, and you can see that the small circle where the Arabian Peninsula exists, you can see that we are having almost zero runoff all year round. I'm not sure if all of you were born at that time, but I was there. In the 1970s, there was a major hike in oil prices, and we have there was a lot of surplus oil money for development, and there has been the whole region experienced accelerated socio-economic development. This brought an increase in our standard of living and health. Our economic base has expanded tremendously, and associated with that, high population growth rates and intensified urbanization. That population growth rate was associated with major and substantial and continuous increase in water demands. These water demands not only for drinking it, they were also to fulfill the needs for food production and industrialization. If we look at one of the indicators that we use for looking at the scarcity of water resources in a region, we take the renewable amount that a country receives, and we divide it into population. So this curve showing that since the 1950, because of the increase in population and the limitation of our renewable water resources, the per capita water share is becoming less and less and less. If these are some indicators or some benchmarks that we are using. If your per capita water share reaches the 1,000 meter cube per year, then you are considered a water poor, country. If it goes to 500 cubic meter per year, then you are really living in the absolute water poverty. And this is where we are now. But we survive. Why we survive? Because we are capital rich. We can manufacture water by desalination. And we also have been using our huge reserves of our non-renewable groundwater resources, which has been accumulating since the Pleistocene era. Currently, our water resources are mainly groundwater. Something like 78 to 80% of our water comes from the groundwater. And then we have desalination, about 20%, and then we have limited amount of treated wastewater being used. Where does this water goes? It goes to agriculture sector, mainly, and then it goes to the municipal sector, with the houses, the urban area, and then the industrial sector takes only 5%. Now, this is the context of the water resource and water uses. I'm gonna try to now go to each sector of these and try to tell you what exactly the main challenge. And overall, it's not an operational. These challenges are not operational challenges. These are strategic challenges. They are long term. They are worrying the policymakers, not the operators, but the policymakers. It's not the leaders of the GCC are really concerned about this type of challenge. The first challenge is the escalating municipal water demands. As I have indicated, that we have high population growth and high urbanization growth, and it is continuing to be. There's no stabilization yet in the population, and this is, I think everybody is seeing this, and not only the water is being used because of population increase, but also because we are not using the water efficiently. If you look at the per capita water consumption in our countries, you will find that if you go to the 60s, 70s, 80s, 90s, you'll find that a person can consuming on average something like 250 liters per day of domestic water. Now, if you look at them, you will find that we are reaching 500 liters per day, 700 liters per day per capita. So imagine a person using 700 liters per day per capita. This is a huge amount of water that's been used. Of course, he's not drinking this water, but he's using it for irrigating his garden. He's using it for his swimming pool. He's using it for many other unnecessary utilization other than drinking. There's also a low efficiency in the water supply, that the water that comes to the consumer before the meter is being lost. That's because there has been a problem in the maintenance of the networks. And then some countries, this percentage can go to 30 and 35%. So the water that's going to produce, very expensive water from desalination, comes to your house. Before it comes to your house, 30% of it goes in the ground, and and actually makes a lot of problems with the infrastructure when it goes to the foundation of building. This is the main problem that's in the municipal sector. And to meet this amount of water, we have to rely on desalination. There has been a huge desalination expansion since 1980s. There are almost like a doubling of every 10 years. We are doubling our desalination capacity. However, desalination is not cheap. It is very expensive. It has, if we can talk about it, the cost of desalination from a financial point of view, you will find that the majority of the GCC countries have very low cost recovery. So the people are not paying the real cost of the service because of the subsidies. So there's a low cost recovery. The other thing is that desalination is very energy intensive, and by that if you want just a number, something like 80% of the cost of desalination actually is an energy cost. This is, of course, an opportunity cost for the GCC countries. If you sell that oil, you will get more money than producing a desalinated water. And there is also the environmental cost that we have a lot of brine discharge for each cubic meter that you get. For fresh water, you have at least 4 cubic meters of brine, or sometimes thermal brines. And there is also the problem of greenhouse gases emissions, because you are using fossil fuel, and there is a lot of greenhouse gases emission, or CO2s. The CO2, SOxes and NOxes, and the CO2s, getting out in the air. It's not only for greenhouse gas emission, but they're also polluting the air, the atmosphere. One of the issues that's really worrying the GCC countries is that GCC countries have almost like 45% of the global desalination capacity. However, and they will continue to have this percentage or share in the world. However, we still don't own this technology. We still are importer for this technology, and it is not adding to our economy. If you own 50% or 45% of the global desalination, you should not be an importer for it. You should be actually an exporter for this technology, especially that you will be living with this technology, for a long time. The other issue is that I think all of you know that we have two types of groundwater: the renewable groundwater, which are receiving some rainfall, and the non-renewable. I'm going to talk first about the renewable groundwater. If you look at the renewable groundwater, you'll find all the GCC countries' renewable groundwater are deteriorating with time. There's a major drop in groundwater levels. We have seawater intrusion. With time, the quality deterioration is everywhere in all the countries, and there isn't a single one renewable groundwater that's really healthy. All of them are being overexploited. And there's also the issue of pollution, that these groundwater, although they are limited, they are not being protected well. There's a lot of activities, agricultural activities, industrial activities, and domestic activities that really pollute these groundwaters, and they make them, rendering them not unsuitable for direct use. This is a map for the United Arab Emirates, and you can see that all the agricultural areas are leaking nitrate to these groundwater, renewable groundwater. Then we go to the non-renewable groundwater, which are they are located in the deep strata in the Arabian Peninsula. They are huge. Admittedly, they are. We have a lot of reserves of those. However, they have been depleted or mined very, very, very rapidly, and mainly by the agriculture sector. Now, if you look at this graph or pictures, you'll find this is the Wadi Sarhan in 1987. There isn't only a small area here that's been used for agriculture, and then in 1991 you can see the rush of agriculture lands, and then 2000, and then 2012. Now, there is no problem in having agriculture, development, but it should be sustainable agriculture development. So there is a question here: what will happen to all these agricultural investment when the water finishes? It's a fossil groundwater, and will finish sooner or later. It will go. So what you will be doing? And we started to see also, now we started to see some of the early signs of having a lot of farmers taking their pivots and moving to Sudan, for instance. So there is a lot of abandonment of this land. The other question is, should I use this for agriculture, or should I use it for domestic or industrial sector, where the income or the return on this of every cubic meter is something like 150 times the return from agriculture? This is also an important question for allocation. Should I use this for agriculture or for domestic? For instance, Riyadh is receiving desalinated water from the Arabian Gulf. It goes something like 350 kilometers uphill, and huge energy is being spent just to push the water to Riyadh. Now, in Al Qasim area, there is a lot of groundwater, and there is also under Riyadh. So if I use that groundwater for drinking, I'll be saving a lot of water and energy from the Arabian Gulf. Should I do that? Should I stop agriculture? And then the agriculture people will say, how about food security? And this is now, the dilemma that all the countries are facing. Should we use this water for agriculture or for domestic? And there is also, should we have this immediate gains, or should we leave it for a long-term benefit? And this is a dilemma. I don't think there's a solution for it, but there should be a consensus for what to do with the renewable groundwater. But it is a major challenge now. The other issue is that there's many countries in the GCC, they continue to grow, they continue to expand in their agriculture to achieve food sufficiency, and without any consideration to the limited water resources. It's not only Saudi Arabia, everybody except probably Bahrain, because there is not enough water and there is not enough lands, but most of the other countries are doing that. Now, agricultural consumption is also highly exaggerated, not only based on the area, but also because of their very low irrigation efficiencies that we are having. And also, there is a trend to go to alfalfa, which is a very high water consuming crop. It can be grown all year round, and it has a lot of demand. It's a cash crop, so people are going there. And there are some, there has been a banning of alfalfa exportation from some country to other countries, and so on. So there's a cat and mouse, fight between the government and the farmers. And also, most of our groundwater wells are not metered, and they are not charged. So they have been used without any cautious. So it's a free water, and it's been used the way the farmer sees fit. The other issue also that we are facing, or major challenge facing, that it's the inefficient wastewater utilization. We don't collect a lot of our wastewater. If you look at the black line here, you'll find that Bahrain is collecting only 50%, 55% of its domestic wastewater, and the same thing for other countries. And if you look at the treatment, we are very good in treatment. So like we are treating almost like 50% and throwing 50%. Oman treating almost every water it receives. Same thing for Qatar, same thing for UAE. But when you go to the utilization, that after this treatment and after all these expenses that we have done, we are not even using these waters. We are throwing them in the wadis, or in Bahrain, at least in Bahrain we are throwing it in the sea after tertiary treatment. This is called major lost opportunities under GCC water scarcity conditions. When you are having all this water and you are not even using it and you are water scarce, this is not good for you. You are not economically, you are losing a lot. There's also the problem of, because we are having a very rapid population growth, we have very high consumption. There is always hydraulic loading on the wastewater treatment plants, and a lot major carryovers are being discharged to the sea, and the majority of which is untreated, and it is causing a lot of harm to our marine environment, and indirectly is impacting our health and socioeconomics of the fishermen. One of the issues that really is a worrying one is that we have a very high vulnerability of desalination plants and water supply system. We rely almost 100% in many countries on desalination, and this desalination takes its water from the Gulf, but there are so many threats to desalination plants, and I have listed them. You don't have to go through them, but we can have any type of pollution that can happen in addition to an actual compass, and these can stop your water supply system immediately. And the GCC countries are, are building reserves, but these reserves are not enough for domestic water supply. This graph shows the traffic of the density map of ship traffic in the Arabian Gulf. It's huge compared to other countries. Oil vessels, commercial vessels, medical vessels, they all cross the GCC. They cross the Strait of Hormuz, and the chances of having accidents is huge. The map below shows the detected oil spills in 2017. Based on this map, which is derived from satellite images, that something like 4,900 detected oil spills happened in the Gulf in 2017, with almost 14,000 cubic meter square kilometers has been the area affected from that.
Hello, everyone. I think Dr. Waleed just got a technical problem. He will be back with us soon.
Okay, yeah. Hello. Sorry about that. سمعوني؟
Yes, we can hear you. We can hear you, Doctor.
I can continue?
Yes, please. Yes.
Okay. Sorry about that. Now we go to issues a little bit different from the other issues. These has to do with the legislation. They have to do with the capacities of the human people, human resources and the institutional resources, data and monitoring, stakeholder participation, awareness. These are it's very difficult to go in details of these, but this has to do with the efficiency and effectiveness and trust and engagement between all the people. This has to do with the water governance. But in general, we have very weak water governance in the GCC countries in terms of institutional setup and legislation, and in terms of participation of the people in solving the water problem. The other issue, which is I think people can relate to, has to do with the future impacts of climate change and variability. The global circulation models and now also the regional circulation models that we have, they have predicted with very high confidence that there will be an increase in temperature, there will be a rise in sea level, and there will be an increase in the frequency of extreme events. So floods and droughts will be more frequent than before. There has been a low confidence in the prediction and decreasing rainfall. Some parts of the Arabian Peninsula will have more rain. Some parts will have less rain in general. But until now, there has not been a confirmation by all the models. But we know that the southern parts of the Arabian Peninsula will have more rain. At least there is a consensus that this will happen. We are not sure about the central Saudi Arabia or central Arabian Peninsula if it's going to happen or not. In either case, such impacts will introduce very high degrees of uncertainty in water planning and management. But they will definitely add more stress on our already stressed water resources system. We know that increasing temperature will increase our demand for water, whether for humans or for agriculture. We know that rise in sea level will increase seawater intrusion to our groundwater, our groundwater aquifers, which has already been experiencing seawater intrusion, and we know that the frequency, the extreme events sometimes become disastrous, like the cyclones that happen in Oman and Jeddah. The other issue is that so far, most of the management of our water resources are happening in a sectoral way. Like the agriculture are doing their job by themselves, the water by themselves, the sanitation by themselves, the cleaning by themselves. So there isn't an integrated planning. And there's always a conflict between these. And the other issue is that we don't look at the demand management side. We always look at the supply side management. Now, if we're going to summarize what I have said in general, that we will find that we are having what we call a downward spiral situation for our water resources management system. Everything is going down, and there is no counter forces that will take it up or will counter where are we heading. And climate change will be an additional stressor. So that's the situation now, and there are a lot of efforts to reverse the situation. There's a lot of efforts to look at the leakages, to increase the awareness, to put some economic tools to increase the efficiency of water resources utilization, and so on and so on. But the stressors or the driving forces are overwhelming, and we need to take a look, stop the traditional approaches, and we move to a different approach. Now we go to the prognosis. Having said all these challenges, this has been in the mind of the GCC leaders and the executives for a long time, and they have directed the Secretariat General of the GCC to develop a unified water strategy for the GCC. And I was privileged to work on this with the team that I will be introducing at the end of the presentation. The Unified Water Strategy project has 6 modules, from data collection, analysis, and then formulation of the strategy, and then capacity building and indicators and office strategy management and all this. I was charged with the formulation of the strategy, which is called Module 3. And this is the work that we have come up at the end of 2 years of extensive work for the GCC Secretary General, and we have presented this work. It has been accepted in December 2016 by the leaders of the GCC countries, and now this is a guiding strategy that need to be translated to at the national level. Many countries have already started this. Bahrain has started already its own national water strategy based on this strategy. Kuwait is in the process, Oman is in the process, and the UAE has already done the strategy, and Saudi Arabia as well. The strategy vision statement look at the future, that we should have a water resources management system that's sustainable, efficient, equitable, and secure. The mission statement is that we have to join our forces, okay, and make some joint initiatives like acquiring desalination technology, like benchmarking our water supply and sanitation utilities, like water security, and also we have to level the ground for the other things, like groundwater management at the national level, wastewater reuse at the national level, energy efficiency at the national level, and governance at the national level. These are the essence of the strategy, that we need to work together to achieve certain issues, and we have to build ourselves on the other side at the national level. And we can help each other in moving up in this area. There has been a lot of various projects. I'm not going to go through them. I don't want to waste the time. But there has been 5 pillars that we were, we thought that they do take us to a vision and mission of the strategy. And to achieve sustainable water management system, to have our water resources sustainable, to have sustainable utilization, efficient and equitable, and we have to look at the security issues of our water resources, especially for the domestic water supply. That's a very important topic. And we have to look at the governance and the awareness, and we have to build our economic efficiency and financial sustainability for the water sector. These 5 pillars have cross-cutting issues. Each one have capacity building and training. Each one has an R&D component. Each one is having an environment and ecology perspective, and also taking into consideration the climate change impacts and the future climatic variabilities. We had these 5 things with 10 strategic objectives: acquiring technology development and of desalination, protecting our conventional water resources, maximizing our wastewater, and so on, so on, so on. These are, anybody will be working. Anybody who works in the water sector will think these are common sense. The importance of this is what we should do to achieve those strategic objectives. And and this is because most of the people in the Dhahran Geoscience Society are geologists, and probably they will be more interested in knowing more about the groundwater. And to go over all these issues, it will take us days. So what I have done, I thought maybe I can extract the relevant parts to groundwater and present them to you to see how integrated the system would be for the groundwater management. Having said that, still groundwater is very much related to agriculture, very much related to wastewater, very much related to surface water, and so on. So I'm going to go. These are the things that hit groundwater, directly, in the Unified Water Strategy. Dedicated strategic objective for groundwater. Agriculture impact on the groundwater has been taken into account. Governing groundwater is taken into account. Awareness of groundwater has been taken into account, and the economic cost of groundwater has been also taken into account. So I'm going to go through these very quickly to show you what has been, what is needed actually from the GCC countries, either collectively or individually, to do to raise the level of sustainability of groundwater. This is the first one, to develop and protect conventional water. As I said, we have two types of groundwater, renewable and non-renewable. Now, when you go to non-renewable groundwater, you cannot say, I'm going to make it sustainable. You can only ensure its longevity. You have to increase its age and its utilization, and your targets and strategies will not be technical. It's not like the renewable, that you how much water you get in, how much water you can produce to make it sustainable. Definitely, this water will go. It has to be treated like the oil resources that we are having. It has to be based, the utilization has to be based on a socio-economic management strategies and not technical strategies, which means that I have to maximize the utilization and the benefits from that for the long term possible. The second objective has to do with the renewable, and this is very straightforward, that you have to reduce your extraction to make them balanced with the recharge that you are having, or at least you have a certain amount of deficit that you, what we call a tolerable safe yield deficit. We have to utilize, with the climate change, we are seeing there is a lot of surface water surges in the region, and we have to have plans to have managed aquifer recharge and water harvesting programs. Without monitoring our system, we cannot take decisions, and we are emphasizing this part a lot, especially for groundwater. It is very expensive to have a monitoring network. It is because of a special, and because also the political side, that there are so many people don't like their lands to be entered for and their wells to be inspected, but this has to be enforced. And if you are, since you are Saudis, I think you know that last week there was the water law was published. The king has signed it, and now it is enacted and it is enforced. And one of the items that it gives the right to the water authorities to get into any land and inspect any land and enforce metering of any well that exists in the Saudi Arabia. We don't have this problem in Bahrain. We have metering since the 1980s. So it became like a norm now to when you drill a well, you have to report your pumping rates. We have to protect our groundwater resources from the anthropogenic activities. There should be some protection strategies, and most importantly, you have to have wellhead protection zones, especially for municipal water and municipal water wells that you use for drinking. We have noticed that when we surveyed the people in our region through the strategy, we found that the people we have very skilled hydrogeologists. They are very good in modeling, they are very good in the operation, but the managerial skills are lacking and the modeling skills are lacking. And we should emphasize and build some training programs towards increasing or enhancing the capacity of these people. And the strategy has a capacity building component that is emphasizing this type of thing. If the ministers meet and agree on this training component of the strategy, modeling and managerial skills for groundwater people will be a major component of that program. Then the second strategic objective has to do with agriculture, and it calls for an integrated planning between groundwater and agricultural sector. You cannot continue overriding agricultural policies over the limited groundwater. You should not take any move in the agriculture sector before looking at the groundwater and groundwater authorities, and if they can really give you that type of water, and what is the impact of that agriculture policy in the future. This is very important. As I said, agriculture is very inefficient, and increasing the efficiency is very important. And so you can do that either by implementing demand management policies or moving toward modern agricultural systems like hydroponics and abandon the traditional irrigation systems. Treated wastewater should be utilized to the fullest, and it should replace groundwater, not to expand agricultural lands, but to replace groundwater, to save groundwater. In terms of governance, I think very important. It is. I wish that that people really take this very seriously. It's how to manage your groundwater at the basin level. For each basin, there should be a groundwater management and planning unit. For each basin, every basin there should be stakeholders how much is need to be extracted and how can we make it sustainable. And there should be also reaffirming of the state ownership of groundwater. So far, the individual ownership is the common practice, that when you buy land, you own the water under it. This is not true. There should be this is like oil. It should be owned by the state. It should be public property, and the state will give it to you, give you the right to use it and not to own it. And that should be also, reviewed every period of time, just to avoid having the tragedy of the commons of groundwater. There should be a compulsory metering and abstraction self-reporting. Every well being drilled and consuming water has to be reported, and we have to know. If you don't measure it, you cannot manage it, and this is very important for managing our groundwater. Farmers' awareness, which are the main users of groundwater, has to be built, and we must put a tariff on groundwater, even if it's symbolic. Even if it's symbolic charge, it will give a price signal. The price signal will make some impact on the production of groundwater, definitely. But to let it free, I don't think this is going to help the groundwater. And finally, there should be a polluter's pay. If a person or an industry pollute the groundwater, they should pay for the cleanup, like everywhere in the world. So far, people are polluting without paying any price for that. These are the things that related to groundwater, and as you see, they have to be they have to be implemented as a package, and should not be done independently. To convince the decision makers that these targets and these policies can help you and can save you a lot of money and give you a lot of efficiency, you will have to give them some numbers. You have to do some modeling. So we have used the WEEP modeling system to model every country conditions, and we have run a reference scenario to say that this is what you're going to be doing. You're going to continue doing this water policies. You will not intervene in the system. You will focus more on the supply side management. You will not try to impact or modify the consumption. And let's see where are you taking us and where the water sector will go. And let's calculate the cost in terms of finance and economics and environmental cost, and see for each country what will happen. And then we started to play with some scenarios that we have put in the strategy to reduce per capita water consumption, to reduce the leakage, to increase the irrigation efficiency, to collect more treated wastewater. All these things, all the scenarios has been made, and then we said, okay, let's see how much cost is there compared to the reference scenario. I cannot I cannot present all the results within this short, intervention or presentation. I just will show you the most important ones. This is for the municipal water supply savings, that we said that if you continue like what you are doing now, this is going to be the consumption, the demand that will be required for each country by the 2035. And if you apply leakage reduction to 10% only, okay, and reduce your per capita to consumption to only 250 liters per capita per day. This is a lot. Still, 250 is a lot, but just reducing it to 250 liters per capita per day, what will happen? And this is the graph that shows how much reduction, how much potential of reduction. These reductions, we can calculate them in terms of not only financing they will be saving. So we have found that we can save up to $56 billion just by doing these things. The requirements, savings, and if you are, because we have signed a lot, because we have signed the Paris Climate Change Agreement, and we have now the nationally determined contributions that we have to reduce our greenhouse gases emissions. Okay, we will be reducing something like 422 billion ton of CO2 equivalent, and because of all this system, we will think, and the treatment cost of that will be something like $16 billion. This is only in a period of from 2016 to 2035, so something like 20 years. And then we went to the other part of the equation, which is the agriculture and groundwater and wastewater. And we found that if we continue with the irrigation efficiency and reducing it, enhancing it to 60% only. Now, I mean, people are shooting for 70 and 80. We are just talking only about 60% only to increase our irrigation efficiency. And if we increase our wastewater collection rate to 60%, which is very low still, but just only having going to 60%, that we will find some very interesting results. That Bahrain, Kuwait, and Qatar, they don't need to produce any groundwater. They can use all the wastewater they have to fulfill their agricultural water demands, which means they can really let the groundwater, recover if they have renewable groundwater. For Kuwait, for UAE, something like 50% of its water supply needed for. So if they continue to go with the same irrigation policy, with the same, agricultural policies, this will not be, the treated wastewater will not be able to fulfill their needs, not only because it is in volume, but also because the urban areas that we are having that's producing the wastewater is far from the agricultural areas that's been where the wastewater has to be used. These are the results has been presented to the executives in the water sector, and they were very happy to see this, but still to move from this point to that point, it will take them probably some time. If I'm gonna end up with this, concluding, we have to, people who are responsible with the water sector have to start thinking of shifting from sustainability of supply to sustainability of consumption. It is the demand that, and if you recall at the beginning, I said, can we have sustainability in the desert? Can we have sustainability of desalination? Can we have sustainability of non-renewable groundwater? All these questions tell us that you can't have those. You can have only sustainability of consumption, that we have to be rational in your utilization. We think also the GCC Unified Water Strategy has put a lot of ideas and a lot of directions to really cope and adapt to water scarcity in GCC. As you have seen from the scenarios, that if you do these policies, you will have a lot of benefits, and they can help you move in the future, and you can continue to serve your development goals. However, if you fail to implement some of those, the cost will be increasing with time, financial, economic, environmental. Maybe it will turn eventually into a social cost that you will be hindering your socio-economic development goals in the future. Before I leave, I would like to give credits to the people who worked on the Unified Water Strategy formulation. They came from all the GCC countries. I had the privilege to be the leader for this group in module 3, which is the formulation of the strategy. But the project was large, and we all worked together. And also, credit goes to the director of the Electricity and Water Department in the GCC Secretary General, who was a very helpful person to the team. The team has worked for 3 years and produced a very good piece of work. And all these 3 countries, all those people are actually nationals from the region. And by that, I end my speak. Thank you very much.
Thank you very much, Dr. Waleed, for this very informative and enlightening session. I think it's very important to all of us, especially when looking at these numbers and what the future holds. Now we will move to our Q&A session. I think you have access to the questions. So please, you can go through them and see the ones that you think are very relevant to the discussion here. We'll have 5 minutes for maybe a couple of questions.
I'm sorry it took so much time.
No, that's okay.
I think the cut took some.
That's very interesting.
I have somebody who's requesting a copy. Yes, I send you just an email. Send me your email, I'll send it to you. Or I can send it to Abdullah and you can take it from there. Okay, somebody says, that's it. I don't have, somebody is blessing me from, from all evil. So Allah yahfadhkum min kull shar. So I don't have a problem with that. There is another question. Any questions? Oh, okay. There's another in the Q&A. Okay, let me go through them. I think I was looking at the chat. So I am Dr. bin Afi from KFUPM. So thank you for the information. My question is about rainwater harvesting from your side. Could it be potential source for water? Yes. If you can collect, rainwater harvesting is a very has a high potential in GCC. Even in Bahrain, when we have a flat area, we still think that there is a lot of water that can be, especially with the climate change, that we have a very short very short period pores of rainfall, and with the extreme events, I think the chances will be there. I think the best thing, I don't think rainwater harvesting is, I would go for aquifer recharge. I would go for rainwater harvesting for the purpose of manage aquifer recharge. That will be more conducive for for saving that water. And it is. Is anybody hearing me? Abdullah, are you hearing me?
Yes, doctor, it's clear.
Okay. It's like talking to yourself, So I think rainwater harvesting is very important to be explored. And if you are living in this part of the world, I think you can see that there is certain time of the year that we have a lot of heavy rain. Now, it is a cost-benefit analysis. How much of engineering structure you will be building to get that amount of water? Is it really worth it or not? But I think using nature, I think we can do that. And somebody has already mentioning that, to lowering pressure of non-renewable groundwater. Why don't GCC utilize the groundwater from uninhabited? There is I think in Saudi Arabia, I think there is a suggestion that to take the agricultural areas, groundwater, and send it to Riyadh or provide it to the water. I think that will be it. But I don't think there are uninhabited areas that there is a groundwater with uninhabited areas. I'm not sure about that, but I don't think I have got right the question. Do we have uninhabited areas with the groundwater in Saudi Arabia? I'm not sure. It is good that GCC have developed water strategy, but I believe that application of this strategy require enough number of well-educated and trained technical managers. Yes, I agree with that. Just have difference in that. Yes, I agree. Fast tracks for creating groups of this. Yes, this is a very important question. As I said in my presentation, that we have a module that's only for capacity building, and that module has a lot of training packages for all groups, not only for the groundwater people, but every group. And we have diagnosed the shortages that we are having in the GCC, and we found that, as I said, that the people who are working in the groundwater field, they are very good professional drillers, geophysical logging, field hydrologists, everything you can think of. But when you go to the managerial side, you see there is a lack of understanding of the other issues like cost benefit, like environmental, like economics, like social, dimensions of management. Take for example, you have now a groundwater resource, and the users there are farmers. It is not a technical issue anymore. It is actually a socio-economic issue. It's also a political issue. So we need to educate our people, the people who are managing the groundwater, and these dimensions. That's why the word integrated water resources management came. That's the idea of having the people. So in my university, I educate my staff, my students in integrated water resource management. I give them the flavor of economics, the flavor of environment, the flavor of social sides. These are very important, and they are actually, management decisions are not based on technical issues. They are based on these dimensions. And hopefully, you see, I will be very frank with you. The package was very good. The budget was there to train the people on this thing. The problem is that what happened in the Gulf, that the ministers, they could not meet until now to decide on this. This is actually what has stopped all these things for 3 years. To create water study centers that can tackle. I don't think you need to create centers. I think you need to, the centers we are having are more than enough. This type of problem. I think we have enough centers to address these issues. If treated wastewater are used for agriculture, what will that hurt our health and consumer? Yeah, okay. This is a very important issue. Wastewater do have risk associated with its utilization. It's not a straightforward, but if you take a precaution and its utilization and treat it well, I think this risk has to be the minimum that can be there. Again, to use treated wastewater is to have, to minimize the risk. You are not supposed to use treated wastewater for like vegetable eating raw. But you can use it for palm trees. You can use it for trees. You can use it for a lot of crops that's not eating raw. But and you have to take risk. You have to minimize the risk by taking the precautions. You cannot just use it as it is. Again, if I have the time, I would have gone through the treated wastewater part, that we have put all the precautions that has to be made before you really utilize it. So it's not supposed to be used just like that. There is a lot of precaution that we have to take care of. There is also a compulsory precaution, not only, it's not only to give it to the farmer and that's it. A farmer has to be obliged. Even here in Bahrain, a farmer has to sign a contract with the Ministry of Works to abide by the regulations of using this water, not for vegetables. Okay, so it is not straightforward. It's a long. I think if I were the Dhahran Geoscience Society, I would make a special seminar on municipal wastewater utilization after treatment for aquifer recharge or for agriculture. I wish I have the time to continue, this discussion. My question: do you think that COVID-19 will increase water consumption? This is very, very, very important question. Actually, we have 3 workshops so far. And I was invited by the Secretary General to attend these workshops at the level of the GCC. Yes, COVID-19 has increased water consumption in the GCC at the domestic level. What happened is that because of the curfews, the people stayed at home. Our consumption pattern changed. People have started to use more water than they used to, because they were before COVID, they used to go to work. Now they are staying at home. Numbers range from 3% to 16% of domestic increase in water consumption because of COVID. The other issue that we also discussed about COVID is that does COVID being transmitted through water? And thank God, our disinfection system is very good, and COVID has no chance, to survive in this disinfection system. And also for the treated wastewater, when you want to use treated wastewater, COVID because COVID also has a viral chilling, which means it goes out with our waste. Again, we were worried about the reuse of treated wastewater and if COVID is there, but alhamdulillah, we have confirmation that disinfection can kill COVID-19 definitely in our system. I think this is the last one. As you said, if 60% is used, some GCC countries would not need ground. So from where this water is produced to have wastewater? I don't understand the question. I don't understand the question, but let me explain what I have said. I said that if I collect 60% of the municipal wastewater and treat it correctly, I can replace groundwater by this treated wastewater. So I don't even need to produce groundwater for the agriculture sector. That's the potential of treated wastewater in the GCC in some of the countries like Kuwait, Qatar, and Bahrain, which are the small countries, because the municipal sector is the main water consuming sector, not the agricultural one. So, Abdullah?
Yes, I think this takes us to the end of our questions there. And with this, I would like to take the opportunity to thank you very much again, Professor Waleed, for this very informative presentation that touches all of us here in this region. We're very delighted in DGS to have hosted you. We've tried in the past, but thank you very much for accepting the invitation at last. Thank you for sharing your
Khalaf was very persistent. Very helpful. He was a perseverant, in getting me, and thank God I got the chance. And maybe it's a good thing for COVID that we don't have to be there. We can do it.
Thank you. That's for sure. Thank you very much. And we'd like to thank our attendees for joining us this evening. We will be very delighted to also have you again in future webinars. And once again, thank you very much, Dr. Waleed, and have a great evening, everyone.
With a pleasure. Thank you very much. and very happy to be with you, and especially that you are all petroleum geologists, and I am petroleum geologist in the first place.
Thank you very much, Dr. Waleed.
Thank you very much. Bye bye.
All right, all the best. Thanks.